Alright, it's time to get back to work on this Evo motor here. Is it 113, I think? Or 107? It might be a 107. It's something. Anyway, I got to, this one had the pulled case studs. So what we did, we got a set of brand new cases here we're going to put on here. So I gotta get this crank fitted up to go into the new case. So we're going to have to measure the bearings and see what we got to do to make them match up. You don't just plug and play the stuff, you should check things. So, these are Ultima cases. These are a lot cheaper than S&S, and I think they're better. They're definitely stronger. It comes with a new tension bearing and some seals and stuff for the other side. We're over here. It went over there. Alright, so the cases are a lot thicker than S&S cases. Now these don't break right here anyway on the motor mounts. Here, you can see how these ones are all solid over here. So it'll be differently. I like the looks of this better than this style, but oh well, you get what you get. But on the inside, instead of being all cut out like this trying to save aluminum, like S&S does now, and I got these windows all cut out. They don't, they're solid. So they're nice and thick all the way through. A lot better. They both have the newer design where they're cutting this back a little bit on the inside. As in there, we'll pull apart, you can see better. But anyway, these are stronger. Problem with S&S cases is this material right here flakes off next to the case race. You can see how this one's missing a little bit. A lot of times it's missing a big chunk all the way around. And that means it went inside the motor, so that's the one where it's got a place to go to. Whereas these guys here, they run a big steel insert in there that bolts in. So it's done a little bit different. This is casting in, that one bolts in. So two different ways of doing it. Alright, let's get this apart, see what we got. This uses all bolts to hold it together and doweled. That one has 3 studs. Once again, this is a little bit stronger. A little bit better, but not stock looking, so that's what you want to do. I like the stock looking cases better, but I don't like the weakness of those. This one has an extra bolt down here to help keep it sealing. S&S doesn't. S&S copied Harley. There's no bolt down in this area. I grabbed that. I did. Not the right one though. Dowel pins are fighting me. Yeah, a little higher. Oh well. I don't like wedging a little bit area here to do it here. More work than I wanted to do. So you see I got two big dowel pins for alignment, so they line up pretty good. You can see it has a big steel insert that's all bolted in, instead of having the cast in steel insert that the aluminum all comes off of, like this one. This one has a steel insert cast into the case. Slightly different. So this is a lot thicker. It doesn't need to be 3/4 inch thick, but it sure don't hurt either. I'm not worried about conserving aluminum. So they're both made out of good metal, so there you go. Okay, this one I don't need right now. Okay, so what we need to do is check our main bearings and see if they match up. If so, I can put the crank right in there, but I doubt if they're the same. And I did not do that last. Just have to reset my caliper and my bore gauge. You got your pin to a different one. I had to use a 40 in there also, as I recall. So you change out the anvil here. You put different washers in there. This just holds it together. It's just a little nut. So now it changes the height of it. This part here is solid. This here is what moves is right here. It makes the dial move, see? Okay, let's see if we're big enough. We are not big enough. Okay, about another 20 more thou it looks like. This might be too thick. We'll see. That works. Okay, so let's go ahead and check this to see where we're at. It's our setting ring here. Just set at 1.750, which is 1 3/4. So we zero out my 0 point here. I guess pretty close. Okay. So I know what size it is for real now. Instead of just comparing, I can actually measure now. Okay, so this is at 10/10 or 1 thou. That's what that number up there, 1 means 1/1000. Every line is 1/10 of a thou. There's 1/10 and a half, 2 turns that around, or I mean taper. 3/10 there, 3, and up here, 1. Alright, so I got about 2 1/2, 3/10 of movement out of this thing. Yeah, about 3 1/2 total indicator reading. TIR. whoopee. Fancy terminology, doesn't mean squat. And that is a rough ass hone. And you can see how it looks like the same number right there. It's about 3, 2, 2, 2. That's pretty damn good. That's one of the most accurate ones I've seen. That's about 3/10 total reading there. Yeah, maybe 2.5. Pretty good for aftermarket crap. S&S and Harley fight over who's the worst, but they're usually 8 to 10 tenths out. What I don't like is the finish. See how rough that finish is right there? It's like a corn cob. See how smooth that one is? That's what mine looks like when I do them. So I don't like this real rough ass finish here. So that is a little bit rougher than I like. So I'm just going to give it a quick flash hone because I don't like how rough it is. So instead of giving it a 3,000 mile break-in, we'll make it so it's only a few hundred miles. Smooth it up a little bit. That'll probably open up a couple tenths doing that, but yeah. Might as well get it loose now instead of later. Okay. So we can go over here and do a little honing. Try not to cut ourselves any sharp ass edges here. So we're going to hone this right over here. Like I said, I'm not going to try to take out much metal, just going to smooth up the surface. Let's see here. All right. So it's a nice fine stone, so it'll leave a nice fine finish. This thing's kind of sharp with my fingers. I'm already trying to cut myself. Okay. Alright, I made a difference already. Looks a lot better already. Still rough, but not nearly as bad. Okay, I'm going to go clean this up. We'll be back. Okay, let's go ahead and pull the bearing off of here. I need to pull the bearing off of here now so I can swap it out. That takes this big stuff right here, which is way up there. A special puller I modified from something else. Don't know what it was made for originally, but just a bearing puller, I guess. modified it quite a bit. There's two pullers in one here actually. So this is an old Dodge or Willys brake drum puller, probably from the 40s or 50s. This works really good for pulling the clamshell puller off. There's a flat spot right here where these here slip in. You just rotate it to a circle. It's fine. That should be enough. All right, now just give it a good yank. My yanking tool. Stinky burn oil smell. See how they come off nice and hard, but they do come off. And it doesn't really damage it any. So you could reuse it if you wanted to. Most other ways to do it destroys the bearing. There you go, one custom made tool. See, I took bolts here and cut them. So these things will go up here and pivot off of these. Get some angle to them. All custom made. I forget where that came from. Up there. That'll work. I think that's how it came off. Close enough. Okay. So now we put the new bearing on here, no problem. These ones need to be replaced, but oh well. Put that down. Okay, I'm gonna go check this for trueness, make sure it's good and true. So I'm gonna go do that. We'll be back.